Hello everyone, welcome to our online class Grade 7 Max Chapter 1 Integers Part 4. Today we are going to discuss about the multiplication of integers. In the grade 6 we learned about multiplication of integer sum rules. So multiplication of two positive integer 5 into 7 equal to 35, 4 into 9 equal to 36. The multiplication of two positive integer is always positive integer. Plus into plus equal to plus. The multiplication of two negative integer is also positive because minus into minus equal to plus. Minus 5 into minus 7 equal to 35. Minus 7 into minus 8 equal to 56. So minus 7 into minus 8. Minus into minus plus 7 8s are 56. Positive and negative integer. The multiplication of positive and negative integer will be in negative because minus into plus equal to minus, plus into minus equal to minus. Minus 5 into 7 equal to minus 35. 2 into minus 4 equal to minus 8. Product of 3 or more negative integer. Product of 3 or more negative integer. We observe that the product of two negative integer is a positive integer. What will be the product of three negative integer? Four negative integers. Let us observe the following example. Minus 4 into minus 3 equal to 12. So you know very well two negative integer equal to positive integer. The product of two negative integer is positive integer. Next B. Minus 4 into minus 3 into minus 2. Let us multiply first of all minus 4 into 3. Minus 4 into minus 3 is 12. Minus 4 into minus 3 is 12 into minus 2. 12 into 2 24. 12 into minus 2 equal to minus 24. Plus into minus is minus. Let's check fourth one. Third one. C. Minus 4, minus 3, minus 2, minus 1. So the product of 4 negative integer. Minus 4 into minus 3 into minus 2 into minus 1. Let's check. Minus 4 into minus 3 plus 12 plus 12 into minus 2 minus 24 minus 24 into minus 1 equal to plus 24. So minus into minus plus. So from the above products we observe that the product of two negative integer is a positive integer. The product of three negative integer is a negative integer. Product of four negative integer is a positive integer. What is the product of 5 integer in? The product of 5 integer is negative. So what will be the product of 6 negative integer is positive integers. So here the hints of the product of negative integers. If number of negative integer in a product is even, 2 terms 4, 6, 8, 10 and so on, then the product is a positive integer. If the number of negative integers in a product is even, then the product is positive integer. Second case. If the number of negative integers in a product is odd, 1, 3, 5, 7, 9 and so on, then the product is negative integer. If the number of negative integers in a product is odd, then the product is a negative integer. Properties of multiplication of integers. Closure under multiplication. Observe the following table and complete it. Statement. Minus 20 into minus 5. Minus 20 is a negative integer and minus 5 is also a negative integer. You get 100 is a positive integer. In this case, three numbers are in integer number line. So the product is also an integer. Second case, minus 15 into 7, you get minus 255. Product is an integer because minus 255 is an integer number. Let's check third one. Minus 30 into 12. Minus 30 into 12 equal to minus 360. Minus 360 is an integer. What you observe? Can you find the pair of integers whose product is not an integer? No. This gives idea the product of two integer is again an integer. So we can say that integers are closed under multiplication. So a into b is an integer for all integer a and b. Find the product of 5 more pairs of integer and verify the above statement. Commutative property. Commutative property of multiplication in integer. We know that multiplication of commutative whole numbers is true. Can we say multiplication is also commutative for integer? Observe the following table and complete it. Statement 1. 3 into minus 4 equal to minus 12. Minus 4 into 3 equal to minus 12. 3 into minus 4 equal to minus 4 into 3 equal to minus 12. So commutative property a into b equal to b into a. Let us check with one example. A is equal to 3, b is equal to minus 6. So a into b, 3 into minus 6 equal to minus 6 into 3. You get minus 18. So commutative property under multiplication is true for all integers. Let's check with 5 more example. Next, associative property of multiplication. Associative property multiplication is a into b into c equal to a into b into c. Let's check with one example. So a is equal to 6, b is equal to 2 and c is equal to minus 7. So a into b into c. 6 into 2 into minus 7 equal to, first solve within the bracket, the rule Bodmas rule. 2 into minus 7 minus 14. 6 into minus 14 is minus 84. In right hand side, 6 into 2 into minus 7. Solve within the bracket. 6 into 2 equal to 12. 12 into minus 7 equal to minus 84. Here left hand side equal to right hand side. So associative property under multiplication is true for all integers. Next, distributive property. One of the important property in integers. Distributive property of multiplication over addition is a into b plus c equal to a into b plus a into c. We know that 16 into 10 plus 2 equal to 16 into 10 plus 16 into 2. Let us check if the true for integer also. Observe the following. Minus 2 into 3 plus 5 equal to 3 plus 5 is 8. Minus 2 into 8 equal to minus 16. Right hand side. So a into b. Minus 2 into 3 minus 6 plus minus 2 into 5 minus 10. Minus 6 plus minus 10 equal to minus 16. So left hand side equal to right hand side. Both sides are equal. So the distributive property of multiplication over addition is true for all integer. Okay. Let's check distributive property of multiplication over subtraction. A into b minus c equal to a into b minus a into c. Let's apply the value. A is equal to minus 1, b is equal to minus 6 and c equal to 7. Apply the value in the property of property, distributive property of multiplication over subtraction, minus 1 into minus 6 minus 7 equal to minus 1 into minus 6 minus half minus 1 into 7. Solve within the bracket. Minus 7 minus 6 equal to minus 13. Minus 1 into minus 13 is plus 13. Minus 1 into minus 6 plus 6. Minus 1 into 7 is minus 7. 6 minus half minus 7. Minus into minus plus 6 plus 7 13. So left hand side equal to right hand side. Distributive property of multiplication over subtraction is true for all integers. Multiplicative identity. We know that 1 is the multiplicative identity for whole numbers. We know that 1 is the multiplicative identity for whole numbers. We want to multiply minus 3 into 1 minus 3, 1 into 5 5. Let us check. Check that 1 is a multiplicative identity for integers as well as. Observe the following product of integers with 1. This shows that 1 is the multiplicative identity for integers also. In general, any integer a, we have a into 1 equal to 1 into a equal to a. Example 2. Find each of the following product. First one, minus 18 into minus 10 into 9. Solution. Minus 18 into minus 9. First multiply by the negative integers first. Minus 18 into minus 10. Minus into minus plus. So 18 into 10, 180. 180 into 9, you get 1620. For the second case. Minus 20, minus 2, minus 5 into 7. Solution. Minus 20 into minus 2. Minus 5 into 7. Multiply the negative integers first. Minus 2 into minus 5 is plus 10. Minus 20 into 10 is minus 20. Minus 20 into 7. 1400. Minus 1400. Third one. Minus 1. Minus 5, minus 4, minus 6. See the sum all numbers in negative. So use the rule of product of integers in negative. 4 negative numbers you have, the answer will be in positive. 3 negative numbers means you get a negative integer. 2 negative integer means you get a positive integer. So let us check. Minus 1 into minus 5 is 5. 6 into minus 4 is 24. So 24 into 5 is 120. Example 4. In a class test containing 15 questions, 4 marks are given for every correct answer and minus 2 marks are given for every incorrect answer. Subdivision 1. Gurpreet attempts all questions but only of her 9 answers are correct. What is her total score? Subdivision 2. One of her friends gets only 5 answers correct. What will be her score? Subdivision 1. Solution. Marks given for one correct answer 4. So marks given 9 correct answer is 9 into 4 36. Marks for given 1 incorrect answer is minus 2. So marks given for 6. So 15 out of 9 is correct answer, remaining 6 incorrect answer. Minus 2 into 6 is minus 12. Therefore, Gurpreet total score is 36 plus minus 12 equal to 24. The total score is 24. Second one. Marks the given one correct answer is 4. So marks given for 5 correct answer is 4 into 5, 20. Marks given for 1 incorrect answer is -2. So marks given for 10. 15 out of 5 is correct answer. So remaining 10 incorrect answer. -2 into 10 -20. Therefore, her friend's total score 20 plus -20 equal to 0. Her friend total score is 0. Exercise 1.3. Question number 4. Starting from -1 into 5, write the various products showing some patterns to show -1 into -1 equal to 1. So starting -1 into 5 up to -1 into -1. Answer. -1 into 5 equal to -5. -1 into 4 equal to -4. -4. -1 into 3 -3. -1 into 2 -2. -1 into 1 -1. -1 into 0 0. -1 into -1 is 1. Thus, we conclude that the pattern shows the product of one negative integer and one positive integer, whereas the product of two negative integer is a positive integer. Question number 5. Find the product using suitable property. Sum number A. So you know very well different type of properties there in integer. We use suitable property to apply and find the value. 26 into -48 plus -48 into -36. Solution. 26 into -48 plus -48 -36. Here -48, take it out commonly. So -48 into 26 plus -36. 26 plus -36 is -10. You know very well this is in distributive property. So -48 into -10, you get 480. Once again I repeat this, that is distributive property. A into B plus C equal to A into B plus B into C. Next one. -41 into 102. For this case, 102 we can written in the form of 100 plus 2. So that terms in A into B plus C. That is also distributive property of multiplication over addition. So A into B, -41 into 100 minus 4100. Next, plus -41 into 2 minus 82. So adding the numbers you get -4182. So this property is distributive property of multiplication over addition. Question number 6. It's very easy to solve. A certain freezing process requires the room temperature be lowered from 40 degrees Celsius at the rate of 5 degrees Celsius every hour. What will be the room temperature 10 hours after the process begins? Answer. Given. Present room temperature is -40 degrees Celsius. Decreasing the temperature every hour 5 degrees Celsius. That means -5 degrees Celsius. Room temperature after 10 hours. So 40 degrees Celsius plus 10 into -5 degree. 10 into -5 is -50. 40 minus 50 minus 10 degree. Thus the room temperature after 10 hours is -10 degree Celsius after the process begins. Question number 8. That sum is very important. A cement company earns a profit of rupees 8 per bag of white cement sold and a loss of rupees 5 per bag of grey cement sold. Option A. A company sells 3000 bags of white cement and 5000 bags of grey cement in a month. What is its profit or loss? Option B. What is the number of white cement bags it must sell to have neither profit nor loss? If the number of grey bags sold is 6400 or 6400 bags. Answer. Given profit 1 bag of white cement we will get rupees 8 and loss of 1 bag of grey cement rupees 5. Profit on selling 3000 bags of white cement. So 3000 into 1 bag profit is 8. So 3000 into 8 you get 24,000. Loss of selling 5000 bags of grey cement. So 1 bag loss is 5. So 5000 into 5, 25,000. Since compare the two, profit or loss. Since profit less than loss, therefore his total loss on selling the grey cement bags, loss minus profit, equal to 25,000 minus 24,000. 1000 rupees 1000. Thus he has lost rupees 1000 on selling the grey cement bags. Option B. Let the number of bags of white cement be X. According to the question, loss equal to profit. So 5 into 6400 equal to X into 8. X goes to this side, multiplication goes to right hand side, to left hand side, division. So 5 into 64,000 divided by 8. Simplify the term, you get 5000 bags. Thus he must sell 4000 white cement bags to have neither profit nor loss. Thus he must sell 4000 white cement bags to have neither profit nor loss. Question number 9. Replace the blank with an integer to make the true statement. Minus 3 into dash equal to 27. Which number you multiply you get 27. Minus 3 into minus 7 equal to 27. Remaining 3 sums is our homework. Okay students, let's do the homework based on this topic. Exercise 1.3. Find the following products. Sum number 1. Find each of the following products. This chapter we learn multiplication of integer. Use the rule of multiplication of integer. You can find the answer easily. 3 into minus 1 equal to minus 3. Minus 1 into 225 equal to minus 225. Sum number D. Minus 316 into minus 1 equal to 316. How? Minus into minus plus, so minus 316 into minus 1 equal to plus 316. Question number 2. Verify the following. You know very well multiplication of integer, different type of properties. Use the appropriate property. This sum A, 18 into 7 plus minus 3 equal to 18 into 7 plus 18 into minus 3. Which property used to solve the sum? Yeah, it's a distributive property of multiplication over addition. So apply the property, you want to find out the answer easily. First of all, solve within the left hand side, and after that you want to solve right hand side. So both are equal or not, check. Likewise, sum number B also distributive property. Sum number 3, subdivision 1. For any integer a, what is minus 1 into a equal to? What is minus 1 into a? Minus 1 into a equal to minus a. Question number 2. Determine the integer whose product with minus 1 is option A. Minus 1 into minus 22 equal to 22 and minus 1 into 37 equal to minus 37. Likewise, solve sum number C. Question number 5. Find the product. Use suitable property. Already we solved question number A and D. Remaining 3 B, C, E, F, G, H. Using suitable property and find the value. 7th one. In a class test containing 10 questions, 5 marks are awarded for every correct answer and minus 2 marks awarded every incorrect answer and 0 for questions not attempted. Solve the sum. Refer example 4. Question number 9. Replace the blank with an integer to make true statement. Already solved this sum. A is not in homework, so remaining B, C, D is a homework. Okay students, thank you all.